Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Welcome to another episode of Chai with my machine learning heroes, CTDS.Show. In this episode, I have the privilege of having Chai with Alexey Grigorev, who's the lead data scientist at OLX Group. We talk all about his experience of transitioning into the field, how he did it, how was Kaggle helpful. I believe Alexey shares very honest overview of how his university, how much his university was helpful or not, and how was Kaggle helpful, and how should you make the most out of your learning from Kaggle. Alexey is also currently writing a book titled Machine Learning Bookcamp. It's available in early access if you'd like to pick it up. We talk all about the contents of the book, and Alexey even shares advices that aren't specific to the book, can also be applied if you're not reading it, if you're just interested in using Kaggle as a platform. There are many practical advices in this interview, so I hope you find it as resourceful as I did. Thanks to Manning Publication, there will be another giveaway with this episode. So for more details, please scroll down to the show notes in order to participate if you're interested. Now, without further ado, here's the conversation. Please enjoy the show. I'm honored to be talking to Alexey Grigorev on the show. Alexey, thank you so much for saying yes to my request of having chai with me.
Oh, my pleasure to be here. Thank you for inviting me. Hi.
So I want to start by kicking off by talking about your machine learning journey. What led you to starting your journey? How did you get interested in machine learning?
Yep. So for me, the answer is this is probably what you hear from most of the people. For me, it was the Coursera course from Stanford by
Andrew
Ng. Yes, exactly. So when it was out, I attended one of the first sessions, and I realized after watching it, after watching the first lection, the first week, that this is what I want to do. Because during universities, I really liked math, stats, all these things. But after graduating, I could work only as a developer. So there were not so many jobs that required these kind of skills. But when this course was out, when I watched it, I understood that this is what I want to do. So then this is when I started transitioning to data science, to machine learning.
Okay. How did you make the transition, and how would you advise someone to do that in 2020, since the courses might have changed a bit?
Yeah, so when I was actually doing this, it was 2012, 2013, so it was a while back. And this was one of the first iterations, so many things indeed changed. I think the course is still, it's still fine, but it's somehow outdated.
1 year in machine learning is equal to a decade.
Yes. But when I started, I was a Java developer working at a bank. I liked what I'm doing, but
you like Java?
So it's a nice language, but machine learning was more interesting for me. And I knew, okay, this is what I want to do. So how do I do this? And at that time, also maybe other people also watched this course and they realized that this is somebody who they want to hire. They had no idea what they want to see, like who they want to see, what kind of expertise these people should have. And most of them they thought, okay, like PhD seems to be a nice thing, so let's require everybody to be to have PhD in mathematics or physics or things like that. So it was quite difficult to find a job back then. So I also didn't know how to get into the field. Companies didn't know what they want to do. So it was like a bit of like stepping in the dark. So I thought, okay, since they want a PhD, I'll do a PhD. I had only bachelor's, so like the next step for me would be getting master's. So this is what I did. I started doing master's. It was fun. I met a lot of people. I learned some theory, machine learning theory, not so much on the practical side though, except for the thesis. So the thesis was pretty useful and practical. It was like application of machine learning to solve a real life problem. For me, it was about extracting mathematical formulas from Wikipedia pages and understanding what each of the identifier there means. Like, for example, E equals mc squared. So E stands for energy, m is mass, and c is speed of light. So things like this. It was pretty exciting. But for me, now when I think about this, I don't think masters was that useful. Yes, it was fun, but in terms of my career, in terms of learning machine learning, maybe it wasn't that great. So it was 2 years, and I think these 2 years I could have used more efficiently, more effectively. Because when I think how I learned machine learning, so it was not because I watched lectures at university, but because after this, after not understanding this, I went home and watched online courses to just to understand it better. So I didn't really need a university for that, right? So I could just go to, I don't know, Coursera or any other online course and watched it and do it. Like, for example, like there is a good course from Caltech University, which I watched in addition to my machine learning course, which made things a lot clearer. And then it helped me do my homework, right? So I didn't really need to go through all these troubles if I could just watch all these courses. And other mistake I did, I didn't really spend a lot of time on doing practice. So I spent these 2 years learning theory, trying to solve all these problems, trying to really understand how things work. But without practice, it wasn't that useful. And when I graduated, I didn't have many problems finding a job because like after 2 years, companies actually realized that PhD maybe is not that needed. So and I actually got hired because I had experience with Java, because of my engineering background. So it seems like that 2 years, I really didn't need to spend these 2 years on masters, right? And when I really learned machine learning was when I started working. So this is when I really started to understand machine learning, not just from theory, but also from practical side. So of course, projects at work, but also my colleague at work, Abhishek. I had a great pleasure to work with him. He's now 4 times Grandmaster. So he convinced me, so he convinced me to give a try to Kaggle. So I was hesitant a bit. I thought, okay, I tried this once in an online course. It's like something related to the Titanic. Like, why do I need to spend time on that? But he convinced me. It was, the first competition was, I didn't do that well. It was pretty awful, like somewhere in the middle of leaderboard. But it became so addictive. So the next 6 or 9 months I spent doing Kaggle, learning something every day. So I think my advice, if you want to learn machine learning, is you don't need to do masters. You don't need to spend two years on that. So while I enjoyed these 2 years, I think if instead I did online courses, I did pet projects, I did Kaggle, it would have been a lot more effective and more relevant to what I'm doing now as a data scientist.
That's one of the most honest answers on the show. I think many people also fall into this trap of assuming that if they're doing the homework, which is more theoretical, they're actually doing machine learning, which is at least not at all related to how it's in the industry.
Yeah.
I want to now switch gears. We'll come back to these topics, but I want to talk about a resource which I think will be very helpful for people who are transitioning into the field. And before we talk about your amazing book, it's titled Machine Learning Bookcamp for the audience. This is a question by Vladimir Ploshe and Mira Dania from Twitter. Why did you decide to write the book? What was the motivation behind it?
Yeah, so I always wanted to share knowledge. So when at university, I tried to explain things to my to my fellow classmates. When I graduated, I also wanted to, every time I learned something, I wanted to write a blog post about it. So I really liked doing this. And then for some time, I once I got approached by Pact Publishing, as they asked me if I can be a technical reviewer for their books. So I started reviewing books for them. It was pretty nice experience learning the book even before it was published. I got to review a few very nice books. But then after, I don't know, 10 books maybe, they said, "Hey, you're so good at reviewing books. Maybe you can write one." And this is how I wrote my first book about Java. So I knew Java well, I knew machine learning, so I figured out that this could be a good intersection, like a good niche area. So I wrote a book about that. It wasn't selling that well, unfortunately, because right now Java is not that interesting when it comes to machine learning. It has a niche, but this niche is probably too small right now. So the book isn't selling that well. But then I co-authored. I was a co-author for another book, TensorFlow deep learning projects. So it was about each chapter in that project, in that book, was a small project in TensorFlow. And I really like this approach of learning by doing projects. So you have a chapter, there is a problem, and you have a solution of like you need to do these steps. I think it's a really good approach of learning machine learning and anything in general. So you first have a problem, and then this is how you solve it. Not like at university, this is the solution, and then maybe at the end of the course we will tell you the problems you can solve with this. So this project-based learning, I think it's really great, and this is what you do on Kaggle as well, because you already have a problem and you try to focus on solving this problem. So it comes first like from the problem, and then you try to solve it. But this book, this TensorFlow deep learning project, it wasn't really friendly for beginners. So it assumed some knowledge already. So it was aimed at more experienced people.
So this is for TensorFlow 1.2 ecosystem, right?
Yes, I think so. But then I realized, okay, I want to write something for beginners. So something for people who just start in this field, who already know how to code, but want to switch to machine learning. For somebody like me, a while ago when I was considering transition into machine learning career. So I wanted to focus on beginners, teach them the basics, and do it through a series of projects. And this is how I came up to this idea of writing a book.
Okay. What all do you cover in the book? I think a few chapters are already out. Manning follows this early access program. And what are the prerequisites? Do we need to have some software engineering experience, or who's the reader?
Yeah, so the reader is, like I said, somebody like me who is a software engineer, maybe has already, I don't know, half a year or a year of experience, and wants to switch to machine learning. So it's somebody who can already program. It can be also a college student who is comfortable writing code in any programming language. It doesn't have to be Python. Python is quite simple. So I think it's for a person who can already program, learning Python wouldn't be too difficult. So I don't assume any knowledge of Python from the reader. But for those who don't know Python, there is an appendix of basic Python introduction, like how you do loops and all these kind of things, like introduction to the syntax of Python. But the chapters, like the main content of the book, it focuses on machine learning. So it starts with the very basics like linear regression, logistic regression, then evaluation metrics, and then it becomes a bit more still basics like what we do in day-to-day jobs. It covers things like deployment of models and tree-based models and deep learning models and deploying deep learning models, and then some aspects that are not really covered in other books, like this whole deploying thing, because usually books, they focus on the libraries. Like, this is how you use scikit-learn, this is how you use TensorFlow, this is how the theory looks like, but they don't go the next step. So I devote a few chapters to actually describe that as well. And there is one chapter which is one step before you actually start, which is about collecting data set. Because for Kaggle, you're lucky. You already have the data sets, right? But in real life, you need to get this data from somewhere. So I think it's quite an important topic. That's why I also try to cover this, because this is what is important for day-to-day job for a data scientist.
And Kaggle also has recognized it, probably, which is why they added another data sets as a tier. It was already there, but now it's a recognized tier.
Yes, yes.
So if you could share a few behind the scenes, I've really loved reading your blog posts, and audience, if you haven't, please go read them right now. But what efforts go into writing a book versus writing a blog post? I think everyone at some point has written a blog post.
Yes. Well, with blog posts, I think it's easier. Well, for me, I cannot spend a lot of time on writing blog posts. Well, first of all, because I need to finish my book. So for me, it takes 1 month, maybe 1.5 months to write a blog post with, I don't know, 10 minutes, 10 minutes blog post. So it takes time.
Yeah.
For book, it takes even more time. So it's quite difficult and time-consuming process, unfortunately. And the way I do it, like before writing a chapter, I spend some time trying things in Jupyter, experimenting. But then I need to actually describe it, write it up, like what actually happens there. And I think it takes like 5 times more time than all these experiments in Jupyter. And the most difficult part of writing is deciding which parts are important and which parts should be omitted. Because when I write, I want to dump everything I know on the reader, right? And okay, this is probably all these things are important. But then I really need to, for each thing I want to write about, I need to think, like, is it really that important? Should I really need to, should I really include this in the chapter? Will it help the reader? Like somebody who doesn't know machine learning at all, like, will it help them understand the main concepts? So for me, it's difficult because in my head, like I think like every important, like every small detail matters, and it results in huge chapters. But for a beginner, it may be just too confusing, like too much information.
Yeah.
So I really have to think, like for each of the concept, like do I really need to include it? And this is the most difficult part, especially when I already wrote something and then I realized this will only confuse the reader. I should leave it out. And that's why it also takes more time. So with, of course, with practice, it becomes a bit easier, but still this part is the most difficult for me.
For books, it's definitely more anticipation for the readers,
Yes.
for you anticipating who the reader is, since it's a longer journey. Do you do the same for blog posts as well? Do you try to iterate over your drafts a lot?
Yeah, for blog posts, I think I first start with the outline and try to think what are the key message I want to send to the reader. And then I also need to imagine who the reader is. Are they experienced developers, or maybe they're only starting? Like, will they understand the words I use? Like jargon words, things like this. When I say AWS, will they understand this? And things like this. So this is something I try to think in advance. But then I simply write and see how it goes. So I try to first have some sort of outline and also key takeaways, but then I just write and see what happens. Usually, the chapter, like the post at the end is quite big, so I need to cut some things out. I tried, like in Medium, there is a nice feature that says you how much time it requires to read the post. So I try to stay within 10 minutes. So I try not to go over, because I know it's quite difficult to read long blog posts. So that's why when I see that the post is big, I try to think, okay, what are the things that are less important for my main message, and then I remove them.
And I'm sure the challenge for you is many people don't enjoy writing long posts, but as you mentioned, you're very attentive. You like to pay a lot of attention to detail. So I think that's where the challenge for you comes in.
Yes.
Once this is also a trap that I keep falling in. After completing a resource, you try to do something, and since the marketing on all of these courses is so strong, you just stay in the learning group. Where should one go after reading your book? Should they Google what is TensorFlow and go read that? Should they look up what is PyTorch, buy a course on that? How should they proceed from there?
Well, ideally, the aim that I have in mind is my book gives sufficient knowledge, sufficient background to actually start working as a data scientist or machine learning engineer. When you go through the series of projects that I prepared, at the end, you'll have a portfolio of projects and enough knowledge to actually go through the interview and do quite well, especially if you do the exercises, because I also prepared some exercises. So if you don't do exercises and say, I didn't get a job, then do the exercises. This is my intention, to give enough background to start working as a machine learning engineer. And in addition to that, in addition to starting working, what you can do and what I suggest, regardless whether you read my book or not, is go on Kaggle. And like, even if you don't read my book, you don't read any other book, maybe you watch an online course. After that, go on Kaggle and try to see how all these concepts, how they appear in real life. Because it's often pretty different from what textbook shows. Textbooks focus on like all these formulas, but in real life, you don't care much about these formulas. You have a library and you just need to get the data, transform it in such a way that you can put it in the library, and then tune parameters, make predictions, these kind of things.
I think
so do that.
Most people fall into two different groups. One is who just assume that Kaggle's easy, projects are easy, it's just XYZ. The other one is who maybe get intimidated by Kaggle and they think, hey, I need to know. They prepare a list of things that they need to know before jumping in. And the truth is somewhere in between, I think.
It was like me. Yes, I thought I need to study everything before I can do anything practical. And that was a huge mistake. So I thought, okay, like, let's say SVM requires a lot of, like, if you want to really understand how support vector machines work, you need to know a few years worth of calculus, then maybe also convex optimization, like all these slack variables, all these Lagrange multipliers, all these things. And when you read it, no, I really need to dig deep and understand all that. But the thing is, you don't. Like, you don't need to know all that, because you can just import it from scikit-learn, put in some data, and understand that support vector machines maybe are not that powerful models, actually. So maybe you should spend time, I don't know, trying to figure out how to tune XGBoost models, not to understand the mathematics behind SVMs.
Absolutely.
This was my mistake, and I realized it too late.
So how would you recommend someone to approach Kaggle, or how did you approach Kaggle, and how has it impacted your work today?
Yeah. So when I tried Kaggle for the first time, I felt completely lost. So the problem was it was a competition from Alien AI company. It was about NLP problem. So there was a question and then 4 answers. Like, it was a multiple choice answer problem. So you need to understand the question and then answer. I had no idea how to actually approach it with machine learning, and I was so lost.
And
but
for reference, this was also after I believe you had completed your masters, and someone would imagine after doing a masters they would know how to do that stuff.
Exactly. And I was already I don't know, half a year at my work, so already I was exposed to some things at work, But still, after that, after 2 years of masters and after working as a data scientist full time, I had no idea how to approach it. And I was curious, like, how do actually people solve it? And of course, forums were very helpful. So in forums, there were discussions like how to approach it, scripts, how to do it. I don't think kernels were a thing back then, but there were some scripts shared on the forums. And then trying to understand what these people did was really, like, it was a great learning experience. So there, the solution was about building a knowledge base from Wikipedia or from somewhere else, and then using this knowledge base to understand like how you can query this knowledge base with the answer and figure out what is the right question. So it's about processing a lot of information, using a lot of external data, and then using things like Apache Lucene or Elasticsearch on top of that to be able to retrieve this information. And then come up with different features like how often this question and answer come together in the knowledge base and things like this, and then training a machine learning model on top of that. So it was super interesting. And then I really enjoyed spending, I think I spent a few months on that. Even though I didn't do well in this competition, I finished somewhere in the middle of the leaderboard. The amount of things I learned, and it also broadened my horizon because I didn't really know that it was possible to solve these problems with machine learning. And this was also immediately useful for my work because at work I needed to work on NLP problems. I also needed to use Lucene. So some of the things I learned there at Kaggle were immediately useful. So I could just take the code I wrote for Kaggle, copy and paste it to my work projects. So it was super useful. And then I took part in other competitions over the next 9 months. So maybe some of these competitions weren't that useful for me. Like it was just, okay, you have like a bunch of tabular, like the CSV, and you do feature engineering and train an XGBoost model on that, and then upload a CSV, like typical Kaggle competition in back in these days. But it was also useful because even though maybe you don't need to build this knowledge base and use Lucene, you still need to make sure that cross-validation is correct, like you have this solid validation framework, and you really learn how to tune parameters. So you really understand how these models, how these libraries work. This was also quite useful for work. Maybe not to the because in Kaggle, if you want to score, like to get a high score, you need to go an extra mile and build these ensembles that are not really useful at work. But still, learning how to set up this validation framework and learning how to tune models was also quite useful for my work. And then one of the last competitions I took part on Kaggle was about duplicate detection. And this topic kind of hunted me after that because I did it quite well there. We participated with Abhishek in that competition. So we did pretty well. We finished in gold in top 10. It wasn't in the money, but I think it was 5th position. So it was pretty well. So I became Kaggle Master after that. And being in the top of the leaderboard is a nice thing because people could discover me. So they, okay, so this person wrote a very nice summary. Like they shared the code in GitHub. They also did pretty well. Let's contact them. And this is what many people did, saying, hey, I have this duplicate detection problem. Can you help me? And then I helped one company eventually to build something like this. But it didn't stop at that. So now I work at OLX, and we need to develop a duplicate detection problem. And who was developing it? Of course, me, because I already I was already solving it. So it happened that this problem and a few others were quite useful for me in my career. So these topics, they kept returning to me, like this duplicate detection. Of course, in real life, it's quite different from the competition because you need to do so many other things in advance.
Yeah.
But the first exposure to the topic and knowing what works well and what doesn't when it comes to machine learning is already quite helpful.
I think That's another promise of Kaggle is these become pet projects which are tested from the industry, because some company actually comes to Kaggle to have the problem solved. So it's not a just out of the blue project. It's a problem that probably matters to one company and surely it has to a few more. So you shared many interesting resources around getting hired as well, I think, on your website and your blog posts. How do you recommend someone should present what they've learned, or how should they make the most out of their learning to get hired?
Yeah, I think what I think works best is learning by doing projects. So instead of just without any system, you take a book and try to read it from cover to cover, it's not going to work, because you really need to have a problem in mind, something that you want to solve. And then you try to find a solution. So you focus on the problem, and then, I don't know, Google or read books or do something else to find the easiest way to solve this problem. So imagine you're learning a new technology, build a pet project. You want to learn a new machine learning model, build a pet project. But don't stop on that. So you have a pet project, go share the code on GitHub. It's not easy, or it's not difficult. Well, maybe it requires some cleaning, but it's not that difficult just to put the code there. And in fact, you probably should start using GitHub from the very beginning. So it's a nice tool to use. But don't stop with that. You tell the internet about this. So write a blog post, share it with your network on LinkedIn, with your network on Twitter. And I think this is enough to get noticed. So just build pet projects, learn by doing projects. So for example, you want to invest time into learning a new skill, just invest 10, 20 times by building something and then share it on the internet. And I think this is enough to get noticed and then also get hired.
Many great people like you. I know, I'm not sure if you're still doing it. You do a weekly tweet thread where you ask people to introduce themselves, and you even further using your platform, you further share their projects as well. So people like you always make sure that students or otherwise have a platform for their projects.
Mm-hmm. Yes.
So how should someone present their Kaggle skills for getting hired?
Well, maybe you shouldn't present Kaggle skills as let me try to put it. So Kaggle teaches you many things, right? And some of the things are very Kaggle specific, like disassembling, finding leaks, right? So don't present that. So because when you say Kaggle skills, there are some things that are like skills that are specific to Kaggle.
Absolutely.
But on Kaggle, you have many good things, right? So and being exposed to a wide range of projects is great. So knowing how to set your cross-validation, how to tune models, that's all useful. And you don't need to finish in top 10, right? Just enough to take part, understand the problem, engineer a few features, and that's enough to learn. And I think this is what you should focus on. So not being in the top of the leaderboard, but just learning enough to know that you're learning. And then this is what you can present later, because this is a pet project. So there is a problem and there is some solution. It's not necessarily the best solution because you didn't go through troubles of creating these big ensembles, but this is a good solution. And in business settings, this is efficient. So focus on presenting that. So try to get exposed to a big variety of projects. It doesn't have to be Kaggle only. There are other platforms. You can also come up with your own pet projects. And sometimes there are the nicest competitions. To me personally, were competitions with certain restrictions. Like, for example, in Kaggle, it's kernel-only competitions, when you cannot use like some people have many GPU machines, and they of course have advantage over people who don't have anything. So these competitions are interesting because they force you to be creative. because, for example, for a kernel-only competition, you don't have a lot of resources. You have only 1 hour to train your model from the beginning to end. You need to be creative. These are competitions where you learn most, and these are also the most interesting competitions to talk, because you had some restrictions, you have some problems, you needed to improvise, to be creative, and if you present that, it is quite nice. There are also other competitions where you have a lot of data. So especially if you don't have a good machine, very powerful, with 128 gigs RAM and things like this, you have to be creative, right? So you have to maybe use some online learning. You don't need to load everything into memory. You somehow need to do it in chunks. This is also quite interesting to present that. So focus on these things. Then try to write a blog post about this, how you approach this. For example, for me, I remember for one of the competitions, I needed to implement a paper, and then I basically shared the results. So it was a competition for click predictions, and the data simply didn't fit into memory. So I couldn't just load everything and train a model there. So I built a model which is called Follow the Regularized Leader, which is basically an online algorithm that doesn't require the entire dataset in memory. So I built that, I shared, I did a few presentations about this approach. It was great because other people also saw value in that, and I did this presentation at work, and we started to use this library at work. So this is my suggestion. So try to find interesting competitions that force you to think creatively, and then also present that. But if it's a usual competition, it's also fine. Just try to take part in as many as possible. Just broaden your horizons, and then present that.
Like you said, in the business world, 80% perfect is good enough. So just if someone just learns from a kernel, learns, not just copies it, and tries to apply it to a problem, that also opens up to interesting talks, projects, even community talks.
Yeah.
Now I want to switch gears to your day job. You working at OLX Group as a lead data scientist. What does a day in your life on non-pandemic days look like, and what challenges are you working on?
Yeah. So with my background as an engineer, somehow naturally happened that I focused more on engineering side of data science. So for example, at OLX, we had some models, but it was a problem for us to scale these models to apply it to 10 million images per day. Or this duplicate detection system that for detecting if 2 ads are duplicate of each other. So using the knowledge that I had from Kaggle and building a model wasn't enough. So we actually needed to productionize it and make sure we can scale to the volume, to the traffic we had. So this is what I'm trying to mostly focus on. And now as a lead, so lead is more like a technical lead, not a team leader. So I don't have a team. I don't lead a team. But I also don't focus on one particular project. I try to focus. I try to get involved into everything, just to know what's going on there, and try to help where the help is needed. I try to mentor people, and often mentoring comes down to these technical aspects. Like when you already have a model, what to do next, how to deploy it, how to make sure it's bringing value to the organization. And this is what I'm mostly doing. So right now, one of the projects we are doing is building this centralized place, ML platform, where we can host all the models. That's one of the projects I'm doing right now. And my day typically looks like I have many meetings with technical people, with non-technical people, one-on-one meetings. Then when I don't have meetings, I try to create some prototypes. And I also like to still stay hands-on, do things with my hands. And often it's things related to infrastructure, like doing some stuff with Kubernetes, Terraform. Because for data scientists, this is often quite difficult. So I try to help there, and also teach how to do this and try to convince people that it's not as difficult as it sounds. Try to show that they shouldn't be afraid of doing these things. So this is what I'm doing mostly.
You've written amazing blog posts on it. Audience can find it in the show notes. In one you mentioned, I think millions of requests are served in one day. How can someone get this exposure if they're not in your position, if someone is interested?
Yeah, so that's unfortunately one of the skills that you cannot really learn yourself by building a pet project. That's unfortunate because, well, it's very unlikely that with a small project you'll get this amount of traffic, right? Like 10 million images per day.
You could do a DDoS attack on your service.
Yes, it's maybe a nice exercise. But I wouldn't say it's entirely impossible because some of the things I mentioned already, competition where I needed to process a lot of data, that the amount of data was so large it couldn't fit into memory. So trying to take part in this competition is also quite useful. Just you don't focus on just loading everything in memory and tuning XGBoost, but trying to work around this problem, try to approach things smarter. I think this is already a good step to doing things on scale.
Yeah.
And in my previous company where I worked, it was a tech startup, and this is where I learned a lot about all these high load, low latency things. And ad tech startups are quite common. So probably in every big city there is at least a few companies that are doing advertisement, and you can learn a lot about large scale in companies like that. So if you really want to get exposure into such things, so my advice would be to just try to get hired into an ad tech company and try to deploy your machine learning solutions there. You'll learn a lot about all these things like outside of typical Kaggle bubble, like how you can approach things to actually make it useful on scale. And I think the main thing I learned in this tech startup is you shouldn't be afraid of trying to get out of your direct job responsibilities. Because typically, like for a data scientist, dealing with things at scale is not a direct job responsibility, right?
Yeah.
So it's a nice to have thing, but it's not directly required. So you don't need to have all this knowledge. So it means that it's not it's not expectation, but don't be afraid to actually try these things. Don't be afraid to get into data engineering and infrastructure topics, and try to do this proactively. And I think even in small scale companies, maybe smaller startups that don't do ad tech or they are not big companies, it's still possible to go a bit into data engineering or a bit into infrastructure topics and get exposure to scale there. So try to do that.
And like you mentioned, working on interesting Kaggle problems under constraints can be helpful. For your case, if I am to give an example, you can make an impact that will affect directly millions of requests every day, even if you can set constraints. What's the number one mistake that you see new engineers making?
Well, I think it's not just for engineers, but for many people in tech, is we focus on the solution, not on the problem. Like in machine learning textbooks, there's like, here how SVM works. This is how decision tree works. So this is a solution, but don't focus on problem. And for engineers, like there is a new shiny framework, and everybody wants to try it, right? And we forget about the problem we want to solve. We forget about the customers. We just want to try this framework because maybe it will look nice on the CV. And I think this is a big problem. I also had this problem. I was studying design patterns. And of course, I wanted to put design patterns everywhere in my code, right? And then it wasn't good for the code. Maybe it was good for me to learn this, right? But the code, it wasn't better because of this. It was even worse. So to overcome it, just stop and think, like, what is the business problem we're trying to solve? Will this new shiny framework help to solve this problem or not? Like, do I really need to use all these design patterns I just learned? Or maybe it's sufficient to write, I don't know, a small function in Python with, I don't know, just 6 lines, and that's enough to solve the problem. Just think about that.
That's great advice. This is sort of a final question. It's a repeat one, but I'll concatenate with another AMA question. What's best advice for someone who's just starting their journey? And I think you'll allude to creating a portfolio. So Bia Chaudhary has asked how to create a portfolio and what projects should they add to it? Should they add Titanic? Should they add simple ones as well?
Well, Titanic probably, no, you shouldn't. Also, Iris dataset probably. So don't.
MNIST.
Yeah. So when I was writing my book, I was thinking, like, what should I really include in my book? Like, what will be the most useful for people who are transitioning their career? And I came up with a bunch of projects for that. So you don't have to buy my book to actually build all these projects, but just build some projects in different areas and put them on GitHub, and this should be a good portfolio. In my case, I decided that the best projects are a project in linear regression when you need to predict a number. So in my case, I decided that the best project is predicting the price of a car, like giving all the characteristics of a car, use linear regression to predict its price. Then for classification, for logistic regression model, it's churn prediction, like trying to figure out if a customer of a company will decide to stop using the services of this company. Then try to not just build a model, but also take one step after that and deploy this model, like use Docker, AWS. So for example, using the same churn prediction model. Then also try to do like a project in tree-based models. In my case, I decided to do a project in credit risk scoring. So when you have if you're a bank and you have customers and you want to give loans to people, you need to be able to know what is the risk that this customer will not return the loan, and you can use machine learning for that as well. After that, it's already enough. Like if you have just these projects and you also touched a bit of production side, it's already a good portfolio to get hired, right? But then you can take a few steps after that and also try to do a project in neural nets with images, some image classification problem, and then also try to create a service for delivering this model, for serving these models, like using Docker, maybe AWS Lambda, or maybe Kubernetes, things like this. This is what I also want to cover in the book. So this is still work in progress. I haven't started writing these chapters yet, but I think it's a good project to have on the portfolio. And then the last thing is collecting a data set. So not just using a data set on the internet, but try to think of a problem and collect the data set for this problem yourself. I think this will be an awesome addition to the portfolio to show that you know how to cover all the steps in the data science process, from the beginning when you think about the problem, then to data set collection, then to training the actual model, and then to deploying it.
Awesome. And I think after you've done that, you can find Alexey on Twitter as well. Share your project with him. Don't please send him errors, tag traces, or silly questions. But as far as I know, you're very kind to even beginners in the field with sharing their projects and giving advices. Apart from Twitter, any platforms that you'd like to mention where the audience can connect with you?
LinkedIn is a good choice, but you can also just write me an email. And
I'll have your website in the show notes for anyone that wants to do so. I think your book will be out by this fall, so still a few months remaining. But thank you so much for joining me on the podcast and for sharing about your book and your journey and all of these advices.
My pleasure. Thank you for inviting me.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.